Hi guys and girls, starting chapter 10 today. Chapter 10 is the beginning of the physics chapters. It's all about motion and how to describe motion. Eventually we'll talk about speed, acceleration, velocity. We'll talk about how to graph motion. And we'll do some problems in there. But this first section is really easy. It is on the principles of motion. If your opening question here is, what do you think we should use for the unit of distance? When we're measuring distance, and you think about distance here in town, like if you go out to the track, they measure that in meters. You run one lap around the track, 400 meters. Probably you guys think of feet, yards. You know, it's 8 miles to the Tyrone School. Everyone talks about that before the big football games and basketball games. We're going to work with mostly metric units of distance. So we're going to work with centimeters, meters, and kilometers. Your vocab words should have been done. You only had 7 this time. Make sure those were submitted, and let's get started. Because we're videoing these lessons, I'm not going to play the videos that are in the slides. You need to access the slides and fill in your notes to do that. While you're copying down your notes, play the videos to yourself. That way I'm not recording myself recording somebody else's videos. An object in motion changes position. Position describes the location of an object. Right now, you're seeing my position relative to either your iPad screen or your computer screen that you're watching this on. If I change position, you're going to see it relative to the background, which in this case is my living room and my TV. If I switch sides over here, you've got a different background. You can see that I was over there, now I'm here. Position is the location an object is at a particular point in time. Currently, I'm over here. To determine position, you must have something to compare the location with. So you could compare it with my computer that I'm running this lesson from, my TV, the whiteboard that I've been using to doodle stuff out on. That's the positioning, or what we eventually call the frame of reference. In position, you need to describe the position using a reference point. You could say that I am to the right of the TV screen. If I'm over here, I would be to the left of the TV screen. Latitude and longitude. In geography class, you guys have talked about latitude and longitude lines. Those are super good ways of using position. In fact, if you guys go on to the military, they use GPS positioning all the time. If you have one of those handheld GPS things, they use latitude and longitude. Position could be also used when you're doing compass drills, like if you're in the Boy Scouts. I know the Boy Scouts use compasses all the time. To measure distance, technically you would want it in a straight line. Things don't always work out in a straight line. For most of our 8th grade class, we are going to be working with straight line motion. Even though that when you're traveling in your car, you're moving back and forth on the highway, you're making right turns and left turns. The standard unit of length in the metric system is the meter. If we're going to talk about longer distances, we go to kilometer. Remember, kilo, the prefix K-I-L-O, means 1,000, so 1,000 meters. Or for shorter distances, we use centimeters. Centi are 100 centimeters to 1 meter. What is motion? Motion is change in position over time. Basically, you started somewhere, you end somewhere else, and then you compare the amount of time that it takes you to do that change. Any change in position is indication that motion has occurred. Motion is described by the direction and the speed. For you guys watching at home or wherever you're watching this video, I am now on the left-hand side of your screen. Over the next 2 seconds, I moved to the right-hand side of your screen. That is describing the motion. Make sure you watch this video at home on displacement. Displacement is how far something has moved from its original place. Let's talk relative motion. Einstein's theory of relativity was huge. Now, we're only going to touch a little tiny piece of it here. Relative motion says that everything has to be relative to the frame of reference. Basically, you're sitting still on Earth, but you don't realize that the Earth is hurtling through space at about 160,000 kilometers per hour. You can't see it. If you look up into the night sky, it looks like the stars are moving, and they are. But also, at the same time, the Earth is rotating. Technically, we are too. So when you're observing motion, you must make it relative to the frame of reference. Here on Earth, if you're watching a ball roll down the street and you're staying put, that's your frame of reference. You're comparing the ball moving to the street. But if you're on a bus going to school and you see your friend running to catch the bus and it looks like the bus is pulling away, that motion is different. Maybe you're on the way home from school and the bus is pulling away and your friends just got dropped off at the bus stop. You see them standing there and it looks like they're moving backwards, but it's actually because the bus is moving forwards. When you look at motion, you must look at frames of reference because you don't know which side of the frame of reference is moving. We'll talk more about that in another lesson. Here is an example of frame of reference. So here's the man standing. He is checking out the hobo in the boxcar. This is telling you that he's not moving, but if this man in the boxcar is moving at 1.2 meters per second, that's the general pace for most average men. But the train is also moving in the same direction at 15 meters per second. This man sees this man. Technically, it would look as if he is moving at 16.2 meters per second because you have to put both speeds together. This is another example of frames of reference. This house is clearly not moving. The man in the bus would be moving. If it looks like the house is moving, it's not because the house is moving, it's because the man in his frame of reference is moving. All right, ladies and gentlemen, I told you that first section was not very hard. Make sure you get that first section read. The page numbers are 313 to 318. There's only 5 or 6 questions. See you next time.